Good afternoon, everybody. Welcome to this afternoon's session. This is Plumbing Definitions. Our presenter is Doug Vance. Doug's most interesting private building industry employment was a partnership in a plumbing business for a period of 6 years, which was mainly with design and installation of building plumbing and heating systems. Doug's career with the City of Coquitlam is managing and guiding a staff of 17, including building and plumbing inspectors. He also composes and writes necessary reports to City Council, is responsible for interviewing of possible staff hiring, assists in preparation of department budgets, and perhaps most important of all, also deals with the day-to-day department business. Continuing interest in the building industry and learning has always been an asset in Doug's career. He is an active member of the following organizations: the BOABC, he was a member since 1992, and the Building Officials Association, he's been a member since 2007. So, without further ado, I'm going to let Doug take it away. Thank you.
Thanks, Catherine. That was when they actually let me into the BOABC. Before they said a plumber wants to be in a building officials? Okay, thank you. Geez, I didn't realize I did all that at work. I maybe should have read that before they said it. Anyways, good afternoon, everybody. I'm going to talk about today about just a great subject that's near and dear to my heart. And I know a few took the level 2 yesterday. I see a few familiar faces, and I feel sorry for you that you have to listen to me again, but such is your luck. Really quickly, a couple of housekeeping items. Everybody, early on when we were doing workshops, when we did have the plumbing officials, and everybody knows that plumbing officials is now dissolved, for lack of a better term. The logo is still up there, and I proudly display it. And I say this at the beginning of every workshop, because I think it's important, the history of organizations like that and the people that came way before me and with me, and the Brian Husbands, Gord Jensen's, Charlie Codes, John Skinners, I could go on, Harry Elsden, Neil Paget, all those important type people that put a lot of work into that organization, that it's recognized. And it's important to me, and I think a lot of the stuff that you're gonna get today came from their beginnings. So. It does mean a lot to still put it up there, even though the organization technically is dissolved. It's now a part of the building officials, and we're happy to be a part of the building officials and provide the membership with what training and help we can. So that also said, feel free. I gave out my email yesterday, and I freely give it out. If you have questions, I'll do my best to answer them as quickly as I can. My email is first initial last name, dvance@coquitlam.ca. Very simple. So if you have questions, I'll definitely try to respond as soon as I can. A couple other things, and it wasn't mentioned in there. I'm also part of the Building Code Interpretation Committee, the BOABC committee. It's made up of different folks with different backgrounds, professional engineers, architects, building officials. The branch has input. Currently, when you see an interpretation as well, there's another piece, and here's some names you may recognize as well. I sit on the committee, but what I do is if there's a plumbing interpretation that's requested by whoever, it comes right off the website, I'll draft it. But I'll run that draft through by James Nias from the City of White Rock. Some of you may know that name. He presents a lot of workshops on plumbing on behalf of the building officials. Brian Husband, the most recent past president of the plumbing officials, and Andy Wilson. Formerly with the City of Victoria, he's now working as an educator at Camosun College on the island. So with those three, I'll take that interpretation, I'll run it by them, then I'll take it to the committee. So it's not just, I don't want anybody to get the idea that it's one person's opinion. It's vetted through quite a few people before it actually gets posted, and I know the 2018 ones aren't posted yet, I get that. There's quite a number of them. Hopefully they'll be up very shortly. With that all said, I wanted to start with the definitions. Definitions in the plumbing code are very important. And I don't say it lightly. I know that there's a lot out there, and I always use the example. And when you're reading the building code and trying to apply a sentence in the building code, you need to know the difference between a fire separation and a firewall. It's really tenfold when you're dealing with the plumbing code. Every piece of pipe in a plumbing system, especially as it relates to drainage DWV is a common term, you'll see in a second, drainage, waste, and venting. You need to know the name of that pipe, and you need to accurately name that piece of pipe in order to know all of the rules that might apply to it. We're going to get to that, because people always ask me why do a special little workshop on definitions, and it is because they are very, very important. If you name it wrong, you can't do anything else. So that's why we take the time to do it. So with that said, we'll start doing it. Usually we do introductions. If you haven't met, we won't bother with it right here. As you can see, the first thing up there said, if you can name it, you can size it, which is true. Doesn't want to stay. Boy, I'm technically incompetent, obviously. Thank you. All right. The third part is water pipe definitions, so broken up, DWV definitions, miscellaneous definitions, and then a moment for some questions. So first thing is we're just going to make you familiar with the definitions contained within the plumbing code. There are a lot that are duplicated, obviously, transferred over from the building code to the plumbing code. And I always preface this with, everyone calls it the BC Plumbing Code. The legal term is actually Book 2, Plumbing Systems. Book 1 is the building code. Book 2 is plumbing systems. It's just a companion document. It is part of the building code. The plumbing code, if that's what you want to call it, is all good. Everybody knows it by that. So there you go. We see that all parts of the drainage, waste, and venting systems, they have definitions in Division A, Part 1. They're all italicized, just like the building code. And then once you've named them appropriately, then you can apply the specific rules. And that could be, there's minimum grade required, how long they can go before you need a clean out, another vent, or there's a change in size required. And that's why it's important. Water pipe systems as well have specific names for parts of the system. However, there's not that many, so that's why they're first. We go really quick through them. There's not too many. Defined terms are on page 1-5 of the plumbing code. You're welcome to follow along, or they're in your handout, either way. With that said, we'll start off with what we think is the most important one, and it's potable. It's a very simple term. It just means it's safe for human consumption, and it's not portable. It's not water you bring in a bucket. It's potable. That's all it means, safe for human consumption. How that's determined, that's a good question. In some areas, you have a health authority that may provide you help with that to ensure that that water provided to that dwelling unit is safe for human consumption. So basically that comes from the Water Safety Act, I think BC Water Safety Act. There's a Canada Safe Drinking Water Act. All of those documents tell you what will be safe for human consumption. We have a long blurb up there. Feel free to read it. That really was in conjunction with some terminology that was thrown around in the industry for a while, mostly related to solar hot water. What they were saying was that the antifreeze solution in solar system was food safe, non-toxic. Those are not defined terms. I don't know what they mean. Food safe, really what it was the stuff that they were putting in there to act as antifreeze. All of you, I'm sure, have gone to a fair or a carnival at some point and got a snow cone. You know the stuff they pour over there to make it red or blue and taste other than ice? That was what was used as the antifreeze, same stuff. The problem with it was when it got heated, it actually turned toxic. What does a solar hot water system do? Heats it. That might be a problem then there's a chance that can mix with your potable water. So that, again, it doesn't have a defined term. You can't really rely on it. I don't know what it is. Plus, there's always a chance, yes, when it's initially put in, they've used some sort of benign antifreeze agent. But what happens when a pump breaks down and they tear that system apart and then they recharge the solar system? And the guy goes, oh, I got to put antifreeze in there. That goes up to the solar panels on the roof. I better get something. And they run down to Canadian Tire and buy some Prestone and throw it in there. Cats go like this when they drink it, right? They turn right upside down and go stiff. Anyways, it's very important to know the potable system, and you don't want anything contaminating that potable water system or any chance of it. Private water supply system is an assembly of pipes, basically a whole bunch of stuff. Pipes, fittings, valves, equipment, and appurtenances, I always love that word, that supplies water from a private water source to a water distribution system. A well, that's likely the most common one. That's a private water supply system. The other one's a municipal system. Here's a big term for you, auxiliary water supply. It's basically a secondary potable water supply from any natural source. We're going to give you a couple of examples of it. So it's any public potable water supply over which primary water purveyor does not have sanitary control. A lot of big words. All it's saying is, I'll use Coquitlam for example. We have a pretty sophisticated disinfection plant up at the Coquitlam Reservoir, right? The Coquitlam Dam. You know that Lower Mainland, for the people around here, if you're not familiar, there's 3 primary sources of supply: Seymour, Cap, and Coquitlam. Those are the 3 primaries. Seymour and Cap are actually codependent. They have tunnels that a couple years ago they dug them, big pipes, and they take it from, I forget which one's the higher. I think, is it Cap, Neil? I think it's Cap. Cap is the highest one. So they bring in the water from the Capilano Reservoir. It goes down that pipe to the what's the other one I said? That's it. Goes in there, they do more treatment, then they pump it back up and they treat it again, and then it goes down into the supply system. In Coquitlam, there's just one, but there's all kinds of treatment that goes into it: UV, chlorination, there's scrubbers, there's all kinds of stuff that happens. I've never even been lucky enough to tour it. I really want to, because it'd be interesting as heck for a dumb plumber like me. But it's very, people, like for a large city, the quality of our water is very, very good. And you hear a lot of stories about how it's not that great. It's very, very good. And there's an annual report that the Metro Vancouver has to put out. If you're interested, you can search it on their site. There was a lot of talk in the past of it was acidic. That has since been taken care of. It's almost neutral. I think the average is 6.8, 6.9, 7 being neutral, right? So 6.8, 6.9 is pretty darn good. There's an auxiliary water supply, and I'm not sure I'd want to drink that. But that is technically an auxiliary water supply. Here's another one, a rain barrel, and this is harvested or recovered rainwater is an auxiliary water supply. Does anybody want to guess at where you might have a use for that? You're not, sorry? Irrigation? Sure. Sure, I'd say that's fine. What you want to watch out for is any interconnection with a municipally supplied water system, right? There can be no interconnection, no physical interconnection. In Coquitlam, and I use it as an example because that's where my experience is in inspections, Fraser Mills, you've heard of Fraser Mills? Used to be the big lumber company in Coquitlam. What started Coquitlam, the city, was Fraser Mills. They actually had a secondary water source, an auxiliary water supply. It was the Fraser River. But they were also on our municipal water line. We told them they have to get rid of it, or we cut them off from the municipal. You get one or the other. You cannot have both. Too much chance for a cross connection. So here's some more water pipe defined terms. The water system, it means a private water supply system, a water service pipe, a water distribution system, or parts thereof. So basically it's just the whole thing. From the main into the dwelling or building, whatever it may be. It's the whole thing. That's a little blurry picture, but it's just a simple water supply system. The water service pipe, it conveys water from a public water main or private water source to the inside of the building. That's it. It ends. There's a picture of what we have in Coquitlam. There's a corporation curb caulk there. That's the city service. That's where it ends, at that property line. There was a good question just asked to me, though. They said the water service says from the public water main. So that needs to be sized from the public water main to the building, to the plumbing code. And the answer to that question is no. It's sized from the property line into the building to the plumbing code. So in our case in Coquitlam, our engineering department has decided that for them, 3/4 inch is fine to service every single family dwelling in Coquitlam. So that's what they put in. If we size most houses in Coquitlam right now to the plumbing code, 1.25 inch water service is required. What our engineering department does, though, is up to them, not up to the plumbing code. The plumbing code takes over at the property line into the building and inside the building, but it does not cover from the municipal main to that curb caulk. And that's basically in the notes. It's the plumbing code, just like the building code, applies on private property. The building code doesn't apply to stairways in the public property, right? You don't need handrails, you don't need guardrails necessarily. Building code does not apply. Did you have a question?
Yeah, what's going on with those houses that they need such a big service? Is it just the fixture units?
Yep.
Or is it sprinkler, or what's going on?
If you size it out to the plumbing code, that's what size comes without any other additional loads.
And that's just straight back.
Domestic load.
Lots of bathrooms.
Yep, we get Coquitlam, they're quite large. I think the smallest that we will see right now is 4 bathroom groups in a single family dwelling. That's about the smallest. Yeah.
So are you requiring them to run 1.25 and then downsize into that 3/4 coming off the main?
I'd say it's the other way around. They're upsizing. They're running in. So, I mean, I take it the way the flow of the water goes from the main in. So in this case, actually, this was taken a few years ago. I don't know if you can maybe see it, but that corporation curb caulk there, the shutoff valve that's at property line, that's a compression type corporation curb stop. So you have to use the compression fitting. You have to. It's not a thread, right? It's a compression thread, which is different. It's a running thread as opposed to a tapered thread. So you have to use that compression fitting in order to make the connection. You can't thread like a 3/4 inch female iron pipe adapter onto it. It doesn't work, it doesn't tighten up. So in this case, that's a little piece of 3/4 inch to allow them to transition, and that's a 3/4 by 1, it's a Filmac is a trade name, Filmac fitting. So yes, they have to now upsize to meet the plumbing code requirements, but we allow that little piece to make the transition. So it's the only way you can do it.
But isn't that negligible since it's
Very.
coming off the main, you're only getting water with 3/4 inch line?
But it's not about that. It's about what does the plumbing code require for the size. In order to meet the plumbing code and to be compliant with the plumbing code, that's the size. What our engineering department determines as a size that works for them is up to them. Because don't forget, if it wears out prematurely on the curb caulk and the city side, who's responsible? And to fix it, and has to dig it up and fix it? The city. If it fails prematurely on the homeowner's side, the homeowner's responsible. And the code is there to protect ultimately the owner. Make sense? I did? Yes, Neil.
Are there any municipalities that have decided to upgrade from the main to a single-family lot to one?
A few that I'm aware of, yes. And Coquitlam, actually, our engineering department is looking at going to one in all new subdivisions. But the old ones will still be 3/4. That's what they'll have. I mean, remember there was a time when they were all half. You know, years ago, we still run into them with services that are 1/2 inch. Things change. The problem was the velocity. It prematurely wears it. So if you have a smaller pipe, in order to supply that demand that building puts onto that water system, the water is going to have to flow through there faster. The faster the velocity, you get a lot of bad things. You get premature wear, you get noise caused by water hammer when it shuts off fast, you get excessive pressure that's caused by water hammer. Now, noise in the ground isn't a big thing, granted, but I would say the premature wear is a big thing, and the possibility that you get excessive water hammer is a big thing. Water hammer comes from automatic shutoffs, right? When they shut up, or actually single lever faucets will do the same thing. They shut off, you can slam them shut very quickly, right? So the water's flowing through there. If it's going through really fast and you shut it off very fast, you get water hammer. Water hammer can increase pressures astronomically. In the ASPE book, I think they say up to 500 PSI. That's not good. Not good at all. Especially when most of the fittings and supply tubes are only rated for about 80, 100, somewhere in there. It's not a good thing. So water distribution system, this is basically, like I said, the water service is basically from the city main inside the building. As soon as you get inside the building, the water service pipe stops. That's it. It now becomes a water distribution system, okay? The water distribution system, I'll bring up the picture, there you go. So we've come above the slab. You can see there's another one of those Filmac type fittings there. Shut off valve, it's at a right angle, gets shut off because this piping system is under test right now. So the valve shut off, so it's only testing the water distribution system. Pressure reducing valve, and then off to the fixtures throughout the building. That's pretty easy system. It's a single family dwelling. Nothing really special. That shut-off valve is required. And here's where I can give you a quick example of where a definition really matters. The water service pipe, like I said, goes from the city main inside the building, stops. So as soon as you're inside the building, on every water service pipe, you require a shutoff valve. So if I come through the wall of a building, like say the water service in this building happened to come through that wall right there, I need a shutoff valve right away. So I need to know that definition right now to know where I require that shutoff valve. That's just a quick example. Right there, I've got my shutoff pressure reducing valve system. So again, it's important to know. Doesn't seem like much, but it is true. A riser, it's just a water distribution pipe that extends through at least one full story. Oh, very briefly, I should go back for one quick second here. Just want to point out something in the water distribution system. If you notice, the term, and I'll just read it out really quickly. It means an assembly of pipes, fittings, valves, and appurtenances that conveys water from the water service pipe or private water system to water supply outlets, fixtures, appliances, and devices. What's the common theme there? There's a common theme when it says pipes, fittings, valves, appurtenances, water supply outlets, fixtures, appliances, and devices. They're all plural. All plural. So that means there's more than one. And that's important because, and I'll tell you right now, because when you size a water distribution system, you're sizing it to the tables in the plumbing code. And you're going to get to a definition, and I'll point it when I get to it, where you don't need to do anything other than go strictly to a table to size that pipe. And that's why it's important. So you need more than one. So if I had I always use the example, if I got a toilet over there in the corner and a basin right there, the pipe coming here to the point of the T for those two fixtures, that is a water distribution system. Because it's plural, there's two. As soon as each pipe goes off that T, that's a different pipe. And I'll show you it in a minute. So there's a riser that extends through at least one full story. Understanding too, you're gonna see later on, story is a different definition. It's a different defined term. It has a different meaning in the plumbing code than it does in the building code. And we'll get to it a little later. Fire service pipe, it's just a big pipe. There's a big one. It supplies a water service, a fire sprinkler standpipe systems inside the building. And you could have a combined fire service pipe, water distribution, or water service pipe, sorry. Fire service pipe, water service pipe. That's fine. It just goes inside the building. Understanding there's different requirements, though, for that shutoff valve when it is a fire service pipe. You still require the shutoff valve. NFPA might not require that shutoff valve right inside the building. Plumbing code would require that shutoff valve if it was combined. So you put the shutoff valve, but what else do you need on that valve now? Needs to be to NFPA, supervised. Supervision means a lot of different things to different people. It may have to be electronically supervised. I think that's all it is. You could think that's the only option now to the code, if I remember right. But there's another requirement because it is a fire service pipe. The NFPA would not require the valve there, but if there was a valve, it needs to be supervised. And the plumbing code requires the valve. Yes?
Just on that.
Yep.
We've got a number of scenarios in our district where our engineering department split the water wall on private property with heat.
Yep.
And there's an interpretation that says that has to be, those valves have to be monitored.
They do. To the building code, they do.
So if your engineering department suggests that, just make them aware of the fact that.
Right. Yeah, we have that equipment, but it's not part of the public infrastructure. It's privately owned. So the owner owns it, but we have the rights to service it. It's like it's more or less an easement, I guess you'd say, because they pay to have it in, we service it, but those valves are supervised. Okay.
If you have a combined system with the fire service pipe, then how do you size it? Is it according to code or?
You'd have to do both. You'd have to do the plumbing code, you'd have to satisfy the plumbing code and NFPA, the hydraulic design. So we'd get the hydraulic design done by, even though they're not recognized, a fire protection engineer. It's not a recognized discipline, much like the energy, those sat in the energy. It's not a recognized discipline, but they are out there and they do the hydraulic design. They'll generally get a professional engineer to seal their drawings for them. So, but they do the hydraulic design. Worst case scenario is definitely likely going to be this fire suppression system, and the potable water just has to be taken into account. And it isn't going to, it's going to be a much larger pipe for the fire service pipe than there will be for the water service pipe for the potable water.
But it's still the service pipe is inside your lot.
From the property line in, correct. But I mean, you still, if they're doing hydraulic calcs for a fire suppression system, they'll actually take that calculation right to the main. Right? So in the case of the pipe, the 3/4 inch pipe might not do it. So if you have a fire service pipe, you got a whole different animal. That's why it's important to know these definitions, right? Know what the heck it is, because if I just did the water service, yeah, 3/4 might be fine. But if I have even on a house, most houses in Coquitlam, I'm trying to think now, the smallest that we've seen with a fire suppression system now, I think more along the lines of 1.5 inches.
Yeah, because we are kind of planning the same thing, inch and a half requirement if you have regular
Yep,
system. So
it's pretty close. Yep. Yep, 1.5 inches is about the minimum, I would say. And we have, in Coquitlam, we're very fortunate because we are so close to the source, we have very high pressures too. So our water service pipe, I mean, I don't think there's many areas that are under 150 PSI now.
Because we do have the water services, we kind of sheet which you get from the professional.
Yep.
And they do that calculation where
Yep.
what is available and what will be generated, required pressure and how.
Yep,
And that's how the sizing will be done.
that's correct. Yep. So water supply pipe, if you remember just a minute ago, I said that I'll have a scenario where I'm going to tell you something else, the other pipe. So I have a lav and a water closet. I had that water pipe coming across the ceiling, hit the T, went to each one. Once the T is only serving that lav and only serving that water closet, that pipe that's only serving that water closet is now a water supply pipe. It's not a term defined in the code, but it's the only definition that works. And it comes straight out of the code, by the way. So bear with me while I get it, because it's not in your handout, but. So when you're doing potable water, it's in 2.6, the plumbing code. So table 2632A, for example, it gives me, and we'll use the water closet. So the water closet that's 6 liters per flush or less with a flush tank, right there, the next column, first is a fixture device, the next one is the minimum size of a supply pipe. And for that water closet, it's 3/8. What size pipe do you usually see to a water closet? It's 1/2 inch at least, but you could do 3/8. People don't do it because that's not what they stock in plumbing wholesalers. They have 1/2 inch and all the fittings. However, that pipe, once I've determined it's only serving that water closet, the water supply pipe size minimum to the code is 3/8. And that's what we say. It's not a defined term, but you need to know what it is. A water distribution system is sized to the requirements in the code. So I would have to get the fixture units, add them up, and then decide what size pipe I needed based on how I was doing it, what method I was using. But once I can determine it's only one fixture, one, singular, that's how I do it. That's it. So you can quickly do, if you can determine that something is by itself, one fixture, that's how you size it. That's why, again, it's important. This is not a defined term, but it's the only pipe left. So by process of elimination, that's what they must be talking about there, right? There's a picture of that one should be easy to tell too, because there's a shut-off valve. That is a supply pipe, water supply pipe to a water closet. because every water closet requires a shut-off valve. So there it is. Now we're going to start doing a little bit of drainage and stormwater. So again, all of these are defined terms, and it's important to know what they are. Stormwater is discharged from a surface as a result of rainfall or snowfall. That's it. That's stormwater. So rainfall, snowfall, and it comes from a surface. Clear water waste is another one that's fairly important. And it has impurity levels that will not be harmful to health. Again, a crapshoot, I don't know what that is, but they give you a few examples at least. It may include cooling water, condensate, refrigeration drainage, air conditioning equipment, cooled condensates. So it may include that stuff. But it doesn't include stormwater. So it's clear water waste, but does not include stormwater. Okay? There you go. Also, drinking fountain is clear water waste. Cooling jacket's another one we give you. Air conditioner, relief valve from a hot water tank, another example of clear water waste. Sewage, it's any liquid waste other than clear water waste or storm. So if you can't identify it as either clear water waste or storm water, it's sewage. The drainage system, it basically takes the waste at the outlets, and it's part of the assembly of pipes, fittings, fixtures, traps, and appurtenances to convey sewage, clear water waste, or storm water to a public sewer or a private sewage disposal system, but does not include subsoil drainage pipes. So footing drains are not included in a drainage system. They're not part of a drainage system. Does anybody know why? Or want a reasonable explanation as to why? Do drainage systems require tests? Be kind of hard to put a test on a perimeter drainage system, I would. Now the problem this creates is a little bit of twofold in some ways. You can't interconnect the subsoil drainage with a stormwater system. You can't interconnect them. Now, I don't know what everyone else does, but in Coquitlam, we have the footing drainage going around the house. Then we have the stormwater system, Rainwater Leaders and everything will be around the perimeter. Separately than the subsoil, two separate systems, we call it a two-pipe system. We can't interconnect the two. The code tells me I can't. But we do it through a sump. So we get a sump put on the site, footing drainage separately to the sump, roof water separately to the sump, one storm water to the city. We don't really interconnect them. We connect them via the sump. But they're completely independent to that sump. So you don't tie the subsoil drainage into the roof drainage somewhere. Another problem with that is what? The storm gets backed up, what happens? Wet basement, very wet basement in a big hurry. Because now you're taking all that roof drainage and especially if it's pumped, then you got a real problem, right? But if you get a plug in that city, even on the private side, it's going back up into the footing drainage and going all around the house. Probably not a good thing, right? So what we do in Coquitlam, if the connection point of that house for the house is lower, the slab is lower, we get a backwater valve on the outlet as well. So if there's any problem in the storm, it doesn't affect the house. It doesn't flow back onto private property. That's another way to handle that. Sanitary drainage is a drainage system that conducts sewage, pardon me. And a storm drainage system, it conveys stormwater. So again, going back to the defined terms, is it stormwater? Is it as a result of rainfall or snowfall? Stormwater. Is it anything other than clear water waste or storm? Sanitary, right? Because it's conducting sewage. This is a building sewer. It's a pipe that is connected to a building drain. Building drain is also a defined term we're going to get to as well. 1 meter outside a wall of a building, and it leads to a public sewer or private sewage disposal. And the building sewer can be either a storm building sewer or a sanitary building sewer, depending on what its purpose is. Is it sewage or is it stormwater? Right? It covers both. Term is the same for either one. So if it has if it's conducting what came from rainfall or snowfall, it's a storm building sewer. The question was asked the other day, if they come outside the building and they run parallel to the building, like right beside the foundation wall, is it the meter distance when it gets past the end of that building and then the meter? Or is it a meter of the developed length of pipe once it's come outside the building? It's a good question. I would say it's developed length of the pipe for a meter. And then the building drain would stop and it becomes a building sewer. That's as simple as I can say that. That would be my take, but that's a personal opinion. Here's the building drain. Just mentioned it said it was a building drain 1 meter outside. So the building drain is the lowest horizontal piping, including any vertical offset, that conducts sewage, clear water waste, or stormwater by gravity to a building sewer. So again, this is important. It's the lowest piping, horizontal piping in a building. Best example I can give you of that to make it clear is if you have a high-rise building, say it goes out the wall at P3 of that high-rise garage, parking garage. That's where the building drain is horizontal. And then your stacks go up into the building, the dwelling units. As soon as it goes vertical and it starts going up, and it can offset, it can do whatever it wants on any other level, that's a soil or waste stack, which we'll get the defined term later. The lowest pipe is the building drain, and only the lowest pipe. Says here there's 2 types of building drains. Want to guess what they are? Sanitary and storm. Well, there's actually 3, but you can never put it in. It's a combined building drain. You can't have it. Combined just means it has both. Storm and sanitary. Can't do it. Code doesn't allow it. There are old parts of Vancouver and New Westminster, very few, that have combined building drains and building sewers. But they don't let them put them in new buildings. They have to run separate out to the property line. And if they only have one main, city main, you wire it together at the property line, then they run that one out that does both. And at some point down in Vancouver, they call it their sewer separation program. They come along and the city crews separate it and put a storm and a sanitary in the city street, and they come along, they dig up to the property line because they got their as-built, they cut those 2 off and they hook them up separately. So they separate it at some point. The plumbing code will not permit a combined building drain. So here's a sanitary building drain. Quick picture. That Y, you can see the open pipe there with a piece of wood and the hose coming out. That's just for the test ball, right? So this sanitary system's under test, but that's going outside the building. So that is clearly the sanitary building drain. And it's also important to know where it ends, at its upstream end, and it goes from the building sewer to the most upstream soil or waste stack branch or fixture drain serving a water closet. And you see the soil or waste stack branch, fixture drain, they're all italicized as well. So you need to know what those are to know where that building drain goes to. And it's important. Anyone want to guess at why it's important? Sanitary building drain? Sizing and now in the new code, in the 2018, cleanouts and the size of cleanouts. You now need a 4-inch cleanout on a building drain. Yeah, like you did 3 codes ago. It's funny, the more things change, the more they stay the same. They go back to where they were a few code cycles ago. But it's important to know. So here's a storm building drain. The picture that's going to come up, I don't really like to represent a storm building drain because it technically doesn't go inside the building. It runs alongside the building there, and then there's a riser there for a roof drain. And then it heads off. It's not really bedded very well either. It's not the best picture of a storm building drain. I would prefer showing one that goes right inside the building, because once you're inside the building, it's a meter out, it stops and becomes a building sewer, storm building sewer. So it needs to go inside the building to be technically a building drain. So here's the combined building drain, and I won't even get into it. You can't do them. So there's no point in even talking about it. I don't know where they got a picture of one. So a branch. Branch is very simple. It's almost like the water distribution pipe. It's connected at its upstream end to the junction of 2 or more soil or waste pipes, or to a soil or waste stack, and connected at its downstream end to another branch, sump, soil or waste stack, or building drain. Basically, it's as simple as I can put it. It's right there. There's a picture. You can see that stub coming up. That's a water closet. Got a 2-inch wet vent heading off there to the basin. That's either a tub or a shower on the right-hand side of that photo. So the branch is basically at the connection of that 3x2 double Y. I've got 2 or more soil or waste pipes. We're going to get to the soil or waste pipe. The soil or waste pipe is any pipe in a sanitary drainage system. So those 2 connect with the water closet. I've got a branch. It's just that simple. And here's the soil or waste pipe I just said. So every pipe that you see in that picture is a soil or waste pipe. Because all it is a waste pipe in a sanitary drainage system. So if you've named it, it's conducting sewage, it's sanitary drainage system. Every one of those is a soil or waste pipe. They're going to have other names too, but they are all soil or waste pipes. Soil or waste stack. It's a vertical soil or waste pipe. So like I just said, any pipe in a sanitary drainage system is a soil or waste pipe. It's a vertical soil or waste pipe that passes through 1 or more stories, and stories is italicized, and includes any offset that is part of that stack. Remember I said the example of a soil or waste stack in a high-rise building, it can have those offsets in the parkades. That's still a soil or waste stack, even though it offsets, still a stack. The other thing I like to point out here in this case is likely I'm going to guess that this is a house, single-family dwelling with a secondary suite. On the right, you can see the waste arm and 2 water pipes sticking out of the shear wall there. That's going to be the secondary suite kitchen sink. And then on the left is a pipe going up to the top floor. There's an expansion joint there. You can just see the white label on it. That's an expansion joint for the settlement of the building. It goes up to the suite in the primary dwelling unit on the top floor. There is no size limitation on a soil away stack. So I've had the question asked to me, well, doesn't it have to be at least 3 inch or go to a water closet to be a stack? No, there is no minimum size to be called a stack. That is a soil away stack. It's 1.5 inch soil away stack. Simple as that. It goes through one story, picks up a fixture on the next story. Passes through more than one or more stories, right? And remember I said we get to it later, but I'll do it right now very quickly. Does anybody know the difference? And you level 2 people, because we did it yesterday, don't say a word. The difference between the defined term for a story in the plumbing code and the defined term for a story in the building code. Do you know what the difference is? That's part of it, but it's not in there. But what's the bigger part?
On the building code, the ground level is not considered.
Yeah, he already said that about the 2 meters from grade.
I can't hear him.
Okay, sorry, but Neil already said that one, but there's a bigger one. Is a mezzanine, is that interval in a mezzanine in the building code of story? Is it in the plumbing code? There's the difference. So if you have fixtures on that mezzanine, that interval between the floor and the mezzanine is a story to the plumbing code, not to the building code. The 2 meters from grade is a difference, but not the main difference for me. So fixture drain, there's the picture. Everybody understands this is the rough in for, I don't know, a fixture, likely a kitchen sink. There's your orange test cap at the end. You can see your test apparatus to fill it up with water. It's 1.5 inches. Maybe it's even the one that was same building that was just on the previous one, for all I know, could be. So the fixture drain is a pipe that connects a trap serving a fixture to another part of the drainage system. So obviously after the rough-in's done and the building's getting completed, cabinets go in, you cut that off, you put your P-trap on, it goes to your kitchen sink, right? So you can see the first red arrow on the right, that fits the definition because it's taking it from the trap to another part of the drainage system. And the pipe below also fits the definition because it's going down to another part of the drainage system. So it would have to tie into like a branch or a soil away stack, then the fixture drain would end. But when it serves only one fixture, it's still a fixture drain. Okay, there is going to be a difference, and it's coming up next. The same picture, trap arm. So the trap arm means that portion of a fixture drain between the trap weir and the vent pipe fitting. So same picture, it's no longer a trap arm on the left there, the pipe that goes down vertically where the test apparatus is. It's not a fixture drain, it's not a trap arm, pardon me, it's still a fixture drain. But this is also, the trap arm is on the right, where it goes from the trap to the vent pipe fitting. That's a trap arm. It's also a fixture drain. So if I'm naming it, I'm going to call it a trap arm / fixture drain, because it's both. And always say when you can name something 2 things in the plumbing code, do it. And then look at what requirements might be special for either one, and it's likely going to be the more restrictive required. So that, for the technical code answer, is a trap arm fixture drain. It kind of even tells you in the definition, right? Because it says that portion of a fixture drain, it's telling you it's a portion of the fixture drain. Fixture outlet pipe. It's a pipe that connects the waste opening of the fixture to the trap serving the fixture. Here's a picture. Hard to see, a little fuzzy. I don't know if you guys can see it very well. Hopefully you can see it in your handout. That one's all cast iron and brass, so likely a high building. Roof drain. It's a fitting or device on the roof to permit stormwater to discharge into a leader. So it's just the drain portion. And this picture actually is a pretty nice installation. That's the pipe. It's all insulated to prevent condensation and all the condensation from dripping all over the floor, right? Because you get, especially in this climate, lower mainland, you get a lot of rain and it's warm in the building and that rain could be right on the verge of freezing, so it's very cold. It hits that pipe and it forms condensation, drips all over the floor. If you don't insulate it, it makes a mess. Used to use the old asbestos cement pipe to do that, but you can't use it anymore. But the roof drain itself is that fitting where it's got kind of the bucket up top, right? It's right in the roof, that's all. Roof gutter is an exterior channel. It's sloped at the base of a sloped roof for storm water. And gutters have to be sized as well, but I don't know how well we do that. You do it, right, Neil? You size them. Engineer. Leader. A leader is a pipe installed to carry stormwater from a roof to a storm building drain or sewer or other place of disposal. Remember I told you in Coquitlam we have the footing drainage is done. In this case, all the drain rock's covering the footing drainage. You can't see it, but you can see all the crushed rock covering it. And all of these pipes around the outside are installed to go up to the roof gutters to get the storm water, right? So those are rainwater leaders. Storm water. We call them rainwater leaders. Technically, they're just a leader. Not L-I-T-R-E, but L-E-A-D-E-R. So a venting system. This is the one place you'll find out what actually a venting system really is installed in a plumbing system. Remember I said DWV, drainage, waste, and venting. We've done the drainage, most of the waste. Now we're going to do the venting. This, if you've ever wondered what a venting system does, here it is. It's in the definition itself, and it's the only place you'll find it of what it actually does. It connects a drainage system with outside air for circulation of air and the protection of trapped seals in the drainage system. Everybody knows what the purpose of a trap is, right? A P-trap under a fixture prevents what? Sewer gas. I heard somebody say sewer gas from entering the building, right? Sewer gas is nasty stuff. It has all kinds of ugly stuff in it. And you don't want it inside that building and be breathing it. So the venting system is installed to protect those traps from trap seal failure. Basically, and I said this yesterday and I really liked it, and I knew it before, but a long time ago in the codes there used to be a design requirement in the plumbing code that a plumbing system was designed to plus or minus 1-inch water column. That's no longer there. But I can give you the reason why it was there. And I tell everybody, because if you design it to at least no more than plus or minus 1-inch water column, then that plumbing system doesn't suck and it doesn't blow. If you have a negative pressure in a plumbing system, it will siphon the P-traps, the water out of them. If you have a positive pressure, it will force the water out the other way. Now, it would take a heck of a lot of positive pressure, but the general theory was plus or minus 1-inch water column. That's what the venting system does. It equalizes the pressure in that system. As the water runs down that drainage system, the venting system goes to outside air, and it equalizes the pressure in there. The old theory of the straw, right? You take a soda pop, you suck on the straw, and you bite it, and you pinch it, and you hold it. The pop's still in the straw, right? It doesn't come out until you do what? let your fingers go. Science, right? Then the liquid will go out. The straw, that'll hold it in there as long as you don't allow the pressure to equalize in that straw. Same theory for a plumbing system. The other benefit of the venting system is the sewer gas has a path to go right through the building and out to outside air. That's it. And that's a key change too, was outside air. Used to say open air. The example I can give you is this municipality we're in right now. They have a lot of their parkades. They don't go down very far because of groundwater, right? So they don't do a lot of basements in Richmond. So they had even their 3-4 story buildings were built on a slab on grade garage that was 3/4 open, that parkade around. And they used to say, well, I can just vent it out into that parkade because it's open air, because it's all open around it. Guys used to try that. Now it says outside air. So that's outside the building. It's important to do it because the sewer gas getting in is nasty. So a vent pipe is basically any vent in a venting system. Same as a soil or waste pipe was any pipe in a sanitary drainage system. Vent pipes, any vent pipe in a vent system. There's just a few examples. Here's back to our same picture again. Probably, like I said, a kitchen sink. This is an individual vent. It serves one fixture, that's it. That one's actually another name as well, but we'll just stick with individual for now. It's an individual vent, one fixture. It's important to know this, and you could say, why, Doug? Why is it important to know all this stuff, Doug? Go ahead, say it. No, I'm just kidding. Individual vent, where can you use an air admittance valve? Now, changed in this edition, but could I use an air admittance valve there? Everybody say yes. Why? Because it's an individual vent. It's one fixture, right? You can replace an individual or a dual vent with an air admittance valve. The dual vent just got added in this edition of the 2018. And I'm going to show you a dual in a second. But previously, it was only this one. So there you go. There's an example of why it's important to know what is an individual vent, Doug? Because if I wanted to know where can I use an air admittance valve, or I was inspecting something and they used an air admittance valve, I'd sure want to know, is that an individual vent? That's the first thing I would want to know. Because if that was a stack, now if this is a second story, and that's technically, every soil or waste stack requires a stack vent, I couldn't use it there. If that's a soil or waste stack, I couldn't use it. Because now I need, if it's a soil or waste stack, I have to have a stack vent, can't use an air admittance valve. This is why I'm taking a minute to explain it, why it's important that these things, you know them. You have to know where you can use certain things. This one's a dual vent, and I can, again, other than for a soil or waste stack and to replace a stack vent, I can use an air admittance valve here, and a dual vent is a vent pipe that serves two fixtures and connects at the junction of the trap arms. Clearly that serves two fixtures, and clearly it connects at the junction of those two trap arms. Going back to the defined term for trap arms. Trap arm connects the trap serving the fixture to the vent pipe fitting for that fixture. So those are clearly two trap arms. That vent's connecting at the junction. It's serving two, it's a dual vent. Continuous vent, it's a vent pipe that is an extension of a vertical section of a branch or a fixture drain. That one, you remember I said there was another name for that vent, the individual vent, because there it is again, that's the individual vent. However, it's also a continuous vent. It fits that definition. So you name it both. It's individual and continuous. That's simple. A wet vent. It's a soil or waste pipe that serves as a vent pipe. It serves as a soil or waste pipe and a vent pipe. So it does double duty. It conducts a drainage for a fixture, but it also vents other fixtures. In this case, it's back to the bathroom group situation. 3x2 double wide, toilet in the middle, bathtub or shower on the right. That's a basin. That's the 2-inch wet vent for that bathroom group. It conducts, it's a soil or waste pipe because it's serving that lav, and it's venting the toilet and the bathtub or shower. So it's going to be, when you can name it a wet vent, it's going to be a bigger pipe because it is doing two functions. It's venting and draining. So a wet vent typically will be larger than a regularly sized soil or waste pipe, typically. The other wet vents over there on the right, maybe it's better seen on your handout. That's likely a laundry. Back in the days when you could have 1.5 inches for the auto washer. But it's a wash tub and an auto washer installation, and the T's are stacked, so they're one above the other. The pipe in between the T's is a wet vent because the drainage line for the wash tub is also venting the auto washer down below it. It's a wet vent. That's a very good common term and one you really want to know because wet venting is probably the most common venting you're going to see in any building of any type, any size. Right out from the carriage house or the smallest one bathroom in a garage or wherever that one bathroom is, up into every high-rise building out there. Every commercial building, every institutional building, every building, wet venting is the most common type of venting you're going to see. Branch vent, it's really the reverse of the branch. In the soil or waste pipe, you have a branch. Now we have a branch vent. Same thing, though. It's connected at its lower end to the junction of 2 or more vent pipes, and at its upper end to a branch vent, stack vent, vent stack, or vent header, or terminates in open air. That should be outside there. Circuit vent. It's a vent pipe that serves a number of fixtures and connects to the fixture drain of the most upstream fixture. Not going to get into it too much to explain it, but circuit venting is really, you're going to only see circuit venting in certain types of buildings, mainly arenas, assembly type occupancies, rec centers, swimming pools. That's where you'll see circuit venting. Circuit venting is done mostly when you have a number of similar fixtures all in a row. So if you have a whole bunch of water closets, urinals, showers, that's where you'll see circuit venting because it uses the least amount of pipe and material and labor to put it in. A relief vent is a vent pipe that's used in conjunction with a circuit vent. So when I have a circuit vent, I also have to have a relief vent. An additional circuit is one that's installed for a couple of reasons in a circuit vented system. When you have more than 8 circuit vented fixtures in one circuit vented branch, you'll need an additional circuit vent, an additional circuit vent. Or if I have a cumulative change of direction more than 45 degrees, I would need an additional circuit vent. And there's just a drawing, I just explained it. So I have 2 45s, that's a circuit vented system. I need an additional circuit vent, that's where I'd put it. Stack vent, I touched on it earlier. If you have a soil or waste stack, you have to have a stack vent. And it goes from the top of the soil waste stack to a vent header or outside air. That's just a drawing that's in the code itself, back in the notes. Thinking this one's out of part 1, division A. So at the end of it, it gives you all the defined terms. If you want a quick reference, it's in the code, and you can look at everything that I've covered here is drawn right there in that drawing. Every vent I've named, every part of the drainage system, it's in one or the other. There's one for the drainage, one for the venting. You can go back through, and that figure is actually quite good. So stack vents, the easiest way to determine, the next one we're going to do is vent stack. I say the easiest way to know the difference is stack vents at the top and a vent stack's at the bottom. That's it. Keep that in mind, because everyone goes, the heck's the difference between a vent stack and a stack vent? There's one quick way to know. Stack vents at the top, vent stack at the bottom. That's it. And there you go. There's, got two for the price of one. So there's the vent stack, and it's a vent pipe that is connected at its upper end to a vent header or that terminates in outside air, lower end to the soil or waste stack, at or below the lowest soil or waste pipe connection on that soil or waste stack. So at or below, you got a soil or waste stack, and it's over 4 stories in height, I need a vent stack. That's what the code's going to tell me. I have to put a vent stack in. So below the lowest soil or waste pipe connection, I take off a vent right there. That's my vent stack. So again, it's at the bottom. The vent header, it's a vent pipe that connects any combination of vent stacks and stack vents. So there's the 3, if you want to call them, the 3 big vents. Vent stack, stack vent, and vent header. Vent header being the granddaddy of them all. So if I connect a vent stack to a stack vent, connect them together, that pipe becomes a vent header. I connect 2 vent stacks together, that pipe becomes a vent header. It's any combination of stack vents or vent stacks. Any combination of 2 or more. And that's just the same drawing for you. An offset relief vent is a relief vent. It provides additional air circulation upstream and downstream of an offset in a soil or waste stack. And there's a picture of it right there. So there's certain rules that apply to when you need an offset relief vent. I'm not going to bore you with the details. Well, I will. 2 or more stories, 100 more fixed units on that upper vertical section. So the upper vertical section is up over there to the right. And if I have an offset that's more than, I think it's 1.5 meters, I need offset relief vents. And I'm going to need them in 2 different locations. I need one, for sure, I have to have one at the upper vertical section, at the lowest soil or waste pipe connection. Then I have a choice of a location of one more, either a vertical continuation or off the side of that lower vertical section. But I need 2. I get a choice on the lower vertical section, but it has to be in a certain location on the upper. And that's an offset relief vent. Air admittance valve, hopefully you all know what those little babies are. I won't get into that too much. Air brake. Air brake is different than an air gap. An air brake is the vertical distance between the lowest point of an indirectly connected soil or waste pipe and the flood level rim of the fixture into which it discharges. So you need an air brake when you take a condensate from a cooling unit over a fixture. You need an air brake. It's not an air gap. An air gap applies to water, potable water. Air brake is kind of when you're doing the sanitary drainage. Air gap is right there. Between the lowest point of a water supply outlet and the flood level rim of the fixture or device into which the outlet discharges. So that's an air gap. It's related to potable water. So if you have an air gap is the best backflow device out there until they put a hose down from it and into the tank that it was over, and you negate the air gap. Backflow is a reversal of flow from the normal direction of flow. That's backflow. Backflow can happen in a drainage system. It can happen in a water supply system. either way. Backflow preventer just prevents that from happening. It prevents backflow. So double check valve assembly, reduced pressure assembly, atmospheric vacuum breaker could be, lots of other devices, right? Those are backflow preventers. Back pressure is caused by when you have higher pressure on the supply side than you do in the higher pressure on the use side as opposed to the supply side, right? So where do you think what's a common source of back pressure in a water system? One that a lot of you probably have in your home. Not really, no. I'm thinking of more, what do you do in the summer when you want to, your guests are coming over? And you want to go to the liquor store, that's the first stop. Right after you go to the liquor store, Neil, you get your gumboots on and you get your pressure washer out and start getting your patio clean for them, right? What do those pressure washers get up to? 300? What's your incoming at? I said in Coquitlam it's about 150, 80. That's the most common source of back pressure you can think of. We had a backflow incident in Coquitlam caused by a pressure washer in our works yard. We contaminated our own water supply. That was not good news that day. Back siphonage is backflow caused by negative pressure. Siphoning. How Neil used to get his gas in the old days when he couldn't afford to buy it. Back siphonage preventer, vacuum breaker, right? That's the most common back siphonage. Now, most hose bibs you put a vacuum breaker on, but if you use that hose bib for a pressure washer, is that vacuum breaker going to stop backflow now? No, it prevents back siphonage only. Back pressure, you need double check valve assembly, depending on the hazard, or an RP. It's the only way to stop back pressure. Back water valve is a check valve designed for use in a gravity drainage system. What time is it? 2:20. I'll try and go fast now. Bathroom group, plumbing fixtures installed in the same room. And it's consisting of one domestic lav, one water closet, and either one bathtub with or without shower, or one head shower. So you can't have a bathtub and a shower, a lav, and a water closet. That's no longer a bathroom group. You've got an additional fixture in there. Bathroom group is or. That last sentence is or. Some people mistake that. So you've got an ensuite, typically you have a shower and a tub, right? And a lav and a water closet. That is not a bathroom group. Check valve. It only permits flow in one direction. Clean out. It's access to clean out a drainage and venting system. Clear water waste. We went through that one a little bit earlier, but it's in here twice. We thought it was so important. Dead end, not that important. Developed length is a length along the center line of the pipe and fittings. Real simple. Directly connected just means physically connected. So two pipes that are joined together are directly connected. Drinking fountain that ends up with an air break over a floor drain is indirectly connected. Dwelling unit, I think that one's in the building code. We're good with that. Emergency floor drain. It's a fixture that's only there for overflow protection. So a floor drain in a bathroom in this building, if there was a floor drain in the bathroom, that's there for emergency purposes only. It's not there getting a continuous flow of any kind. And there you go. That's an important note. There are two types of floor drains. One is emergency and non-emergency is the other one. So those other ones are installed for specific purposes, maybe to pick up a condensate, maybe to get the drinking fountains I just talked about, Those are non-emergency. Emergency's only there for overflow, like you'd see in a mechanical room or a bathroom. Field review, you guys know what that is. Fixture, it's just a receptacle, appliance apparatus that discharges sewage or clear water waste, and it includes a floor drain. So a floor drain is a fixture. I'm going to fly through the last few because you guys are probably tired of hearing me talk. Flow control, roof drain, not important, indirect. There's indirectly connected, just did that one. Nominally horizontal is an angle less than 45 degrees. Nominally vertical is more than 45, right? Of not more than 45. So as soon as I come along with a horizontal pipe, put a 45 on, that pipe is nominally vertical now. That's all that means. Offset just connects to, there's plumbing system, not too hard. Private sewage disposal system is a privately owned plant for the treatment and disposal of sewage. And it gives you septic tank and absorption field. That's a private sewage disposal system. Private use, this one I would say is important to get. All I would take out of this one is don't read it all, read private use, and just go to the end. It's fixtures in residence and apartments, fine. In private bathrooms of hotels, fine. But here's the key. It's for one family or an individual. Know that. So even if you had this kind of building right here in this tower, and I went up there, and there was a CAO of a big company up top, and he had off his big office, he had a little bathroom that was for him and him alone. Those fixtures would be private use because they're meant for an individual. Simple as that. Hotel rooms are private use. Housing, private use, obviously. And I wouldn't get too hung up on public use and trying to determine when. Just if it doesn't fit private, it's public. Private water supply, and there's public use right there. I'm not going to get into it too much. Not going to do these too much because they're... Size is a good one. It's the nominal diameter of pipe fitting trap. Story, there you go. There's the including mezzanine part right there. And that, to me, that's the important difference to me. Because if I have a mezzanine and a fixture, now I have a story to the plumbing code. And there's subsoil drainage pipe. Trap, it's about the liquid seal, trap dip, trap seal depth. Don't worry about that.
So Doug, if you have subway parking,
Hey, good timing. Just kidding. You're awake, I like it, yes. Go ahead.
Subway parking multi-level, and you have a level of that parking that doesn't have fixtures on it.
Yep.
Is it considered a story going forward?
No.
Okay.
You have to have fixtures. However, is a floor drain a fixture? Do most parking garages have floor drains? Then you've got a story. To the plumbing code. Again, you need fixtures in that story, then every successive level is a story. Most parkades I know have floor drains. If you have a floor drain, it's a plumbing fixture, and you have a story to the plumbing code. And the other difference is the mezzanine. Thank you all. That's it.